Hi YouTube! So today I'd like to show you the player movement. In the last video I discussed the state machine that I've used to implement this. I feel like my current workflow is really nice, and in the 2 days since then I've managed to implement most of the movement mechanics that I planned to have. Here's what it looked like 2 days ago. It started out with the basic idle, run and air state. I realized that most of the actual movement code would be same for many states, but that the parameters could be different. For example, both the air, run and idle state should apply friction to the player, but the amount of friction is different when in air or on the ground. So I wanted to find a way for these states to share functionality. I wanted the default parameters to be modifiable, but each state should also be able to override them with their own values. But at the same time, all states do not use all of the functionality. An example could be the dash or slide, where no friction should be applied. So I decided to implement some functions in the movement component, with an optional parameter struct. This fits my requirements perfectly. Here's an example of the declaration for such a function. You can see that all the default values are set directly in this struct. This is the function that will apply a force to the player based on horizontal input. There is one major downside to this approach, that none of the default parameters are exposed to the editor as properties. Fortunately, I'm the only person working on this and I don't mind recompiling, since a change here takes less than a second to compile. The base states are very simple. Here's the entirety of the idle state. You can see that I'm using the look around functionality, I apply some friction, and I apply velocity clamps with the default parameters. And in the air state, you can see how I override certain parameters. Alright, so what's the reasoning behind this? This approach allows each state to do its own thing, with minimal dependencies on other states. In most cases, a state only needs to be aware of another state if it wishes to transition to that state. It means that it's really simple to add or remove states. But why would I want to do that? Well, I'm not yet sure what is fun for the player, so it's reasonable to assume that some of the states I make won't be fun to use, and in that case I will just not use them. Plus, it allows some states to be disabled at the start of the game and unlocked as an ability later. So what about abilities? I'm making a movement-focused game, so I liked some cool abilities. I'm starting with the slide. In order to slide, I first need to crouch. Crouch is its own state, similar to run, but with some movement nerves. You can also see that crouch has plenty of reasons to no longer be crouching. Of course, we should also make the collider small. Now, slide is in many ways similar, but while in slide, you have a constant velocity in the slide direction. There are two unknowns here, slide direction and the check input function. Slide direction is set when entering slide, based on the flattened rigid body velocity. And check input checks if the player is pressing any key and makes sure that the key that the player is pressing is in about the same direction as the slide direction. And the final mystery, what are the conditions for entering slide and crouch, and where do we check them? In slide, check. So we're only going to check this if on the ground and pressing crouch. We will enter slide if we're moving fast enough and we're pressing any kind of input key. Otherwise, we just enter crouch. And that's it. Dash is one of the simplest abilities. Check a key and launch the player. So, here is my dash state. You can see in check that I'm checking the dash cooldown. And then in update, every frame I set the velocity, and after a certain duration I exit the dash. In enter, I set the timestamp Then I set the direction of the dash to the movement input, plus a little bit of upwards tilt. I think I'm going to add that you need to touch the ground between every dash, but that's not currently the case. Wall run. The big challenge with wall run is wall detection. I think I've got a pretty good solution figured out. I make 2 sweeps, to the right and to the left, relative to the player rotation. When a wall is hit, I consider the hit normal. First of all, we don't want to consider hits on the floor and ceiling, so that's why we discard if normal is vertical. Secondly, the hit normal has to be close enough to the current wall normal. We don't want to consider hits from a completely different direction. But life is unfortunately not this simple. Here are 2 common cases that we need to consider. The wall might be really uneven, resulting in lots of hits from strange angles. In this case, I think it would be good to use some kind of weighted average of all of these hits. 2. This is seen from above. In this case, there is a sudden turn of the wall, and the normal will quickly change a lot. I think it would be best if the normal could smoothly interpolate from the first to the second angle. Let's start by solving the first case. We compare the hit normal to the wall normal to get the dot product. We clamp the dot product to a positive range and call that the weight. If the weight is very small, we discard it, and then we multiply the normal by the weight and we use this value. Now, let's use the result for calculating the new normal and solve the second case. You can see that I've expanded the function to include other hits. First off, we reset the target wall normal. At the end of the for loop, we're adding the weighted normal to target wall normal. And then, of course, don't forget to normalize the result and potentially flatten it as well. And then the normal interpolation is done in the state update. And that's it. I feel like this is a good foundation for the movement. There are certainly many tweaks and small features that are still missing. Here are a few that are already planned. I want a wall jump. When you're on a wall, the jump should add some force in the direction of the wall normal. Coyote time. A small duration after leaving ground where it's still possible for the player to jump. Double jump. I think that's pretty self-explanatory. Alright, don't forget to subscribe if you enjoy my videos, and I'll see you around.